We are back in the shed now with the Tandy, and as we saw in the technical guide, here there are some covers that cover up some screws that we need to unscrew and take away before we can get this case off. Yes, there you have it. I tried to take these off so I can put them back in. They're made of quite thin plastic foil. Yeah, but I think I managed to save them. If I can get a grip with this. Yes. Yes, like so. And inside there was some springs, things on the spring. Other end. This spring is actually connected to this small piece inside here. Like so, and this should be fastened with a connector down on the main board. So if we carefully try to expand this a bit. Now it's the floppy drives that's keeping this in place. And this is actually fastened. This is the green ribbon, so it's fastened all the way over here. But I think this connector is loose, and it's fastened here by some other connectors. I'm going to take away this blue one too. The blue one is the one that's closest to the top here. Yes, that was the LCD, and this is the rest. This is one of the springs. The other spring is probably, yeah, it's probably inside or behind somewhere. Yeah, I have to find it afterwards. But first we have to find out what's keeping these down, and this is probably the bracket over here. And here you can see the volume knob that's placed inside the battery compartment. I will turn this around to see if there is something that keeps this stuck behind here. I think it's the modem that has to come out. Yes, I found a way to take off this metal piece from the modem slot, and then it probably will be okay to get it out, because this was fastened with these plastic plunger things here, and these plastic things have this pin stuck in here, so I just pushed this pin down here, and then I was able to take that out. And it actually seems like this modem is not able to slot out of here in some easy way, because it goes against the metal here in some way, And it can be a combination of several things, but I think we will be able to take this bracket out now with the modem inside. Some of these constructions makes it painfully clear that it's the early days of laptop and portable computers, so the placement of the leads and screws are a bit difficult to comprehend. But I end up here actually taking off the keyboard to get to the floppy cable that's beneath the construction itself, and it has a rather short cable, but that's easy to remedy. And now we actually see the barrel battery that we actually came inside to have a look at. Yes, and this is the battery, and it has not leaked, and that is very good news. But of course we do have to remove it, but I will actually measure it first to see what voltage we have here. Yeah, 0.2 volt, that's not a prime battery. I do have to take that out of here, and I do want to have an inspection of the rest of the board, so I will continue to get this out. We might have to do some cleaning of these floppy drives and stuff. There is one more connector inside here that I probably will be able to get out, but the question is, will I be able to put something in here afterwards? It's like so, and we have one more problem here, and that is the on-off switch. And now this modem come loose. This cable was the big problem, and this cable is actually a bit damaged. You have the insulation broken here to the threads here, and you have this card here that is not actually the expansion card. There is one more plug here to take expansion cards, and you do have this expansion slot for the modem, and that's the blue cable here. And you have the floppy drives. They're stacked like this, and the floppy drive cable is the one that actually goes into here. This is the floppy cable. And this small card here is the memory expansion, and it's populated with 81C4 256 12P, and this is memory that's stacked like 4 bits, 256 byte each. So this is actually, I think, 8 bit together, 512K. We leave that in there for now, and we take a look at the main board. This is the NEC CPU, and this is the V20 or D7010 8C8. This is an 8 MHz version of the CPU, and there's the missing spring. And this motherboard is actually based on a lot of custom chips. Remember, this is 88, and it's made by Citizen. Citizen is the same company that made Epson back in the day. Today they are most known for their PUS printers and stepper motors and other stuff. But this is a neatly integrated piece of equipment, and most of the special chips are from Mitsubishi. The keyboard controller, it's this one. It's an 80C49. This is from Oki. You have the BIOS chip, compatibility software, copyright 1995-1996 by Phoenix. And parallel controller and serial controller and stuff for this is made by Toshiba. And you have two small gall ships here that actually stands in a socket. Other than that, it's just the CPU and the BIOS that's socketed. And this is CG-ROM, and this is probably for the screen controller. And this Yamaha chip is what the video card is based on, and this is a CGA compatible chip. The main board itself looks pretty good, and as you can see, there is no corrosion at all around the battery. We do have a really small leak on the battery. I will show you this after I've taken it out. There really are a lot of Japanese parts in this computer. You do have some others, but you are Toshiba, you have Mitsubishi, and more Toshiba, you have Mitsubishi, and there you have a Texas Instruments and a neck chip, and this neck is Logic chips in the 74 series. And here you have some Motorola parts. You have one more Texas Instruments, you have one Fairchild, and this is the memory for the CGA card. Yeah, when we are going to put this together, we will have two issues that we need to carry out in detail before we put the top lid on. We do have to get the floppy cables back in this one, and we do have to put the springs back in these and thread them up where they should be. And as you can see, I actually bent this a bit. It's very soft metal, so I don't think it will be a problem to get this back in shape, but we do have to find a way to actually slot this in after we put it on. I will just take this battery and desolder it. I'm not sure if I'm going to make a replacement for this straight away. I'm not sure what this BIOS is like when it comes to dealing without working without the battery, but the best thing will of course be to just find a replacement. This is not a Varta, it's a Memo Power Yuasa. It's made in Japan. You can see here, this is actually a sign that this is starting to leak down here, and it's probably because the chemicals in the battery has started to crystallize, so they need more space. So this battery had probably been able to take charge and would probably have worked for several more years before this will have been the biggest of problems. And this battery was actually 3.6 volt, and I do think I'm just going to solder in two leads here now and use a coin cell that I can store somewhere else. Yeah, I just think it's time to put this one back together and give it a test. I will, as I said, solder in two leads here first. Yes, I found this wire here. This is actually from an old USB wire, I think. And I'm just going to solder that onto this battery port. And I'm going to draw this back here to the expansion port so I can reach this from the outside. So I will just solder this straight onto the battery poles that's on the main board and just run it out through the back. I'm just going to put some solder on this. Yeah, just like so. And I'm going to see how I run this out the back. And this we has not taken loose. I'm just going to start to assemble this again. You can see here that the floppy drives are screwed in from beneath, and that makes it almost impossible to maintain the floppy drives without actually putting it all together. So I maybe should try to boot this without putting it too much back together, and we saw that LCD it was possible to pull the cable and try it from the outside. So I think it's a change of plans. We just put this as much together as we have to get it operational. Then I have to turn it around to see if I can put the floppy cable back on, because I do think in this stage that will be the biggest obstacle. There are some slack on this floppy cable. Yeah, so I will be able to put it back in like so. This lid was going like so, and then I just pull this like so to get. This is a proprietary cable. I have not seen this exact kind on floppy drive, but back in the day there was all kinds of connectors for floppy drives, but they was mostly compatible, but just not on a pinout level. And that's all together. And we have this one, and we have to do some cable organizing here. This one has to go. Yeah, I think this is the easiest to run it like so. This is for the expansion port. This was also for the expansion port, I think. Yes. There probably are much of an ISA bus out on that expansion port. That's the modem port, and this one was for the LCD. And the keyboard was over here, and this should be put, not sure about the cable management, but yeah, I think this was screwed into the keyboard in some way. Yes, and we do have the power like so, and this is probably standard voltages from the power supply, and that we do have this full set of leads out of the power supply leads me to believe that this actually probably would have been able to run without the battery. We might try that later on. Let's see what we can do to free up the LCD. We do saw that the LCD can loose from the case. That actually is the case. So here is the LCD, and this is a keyed connector. It only will fit like so. And the keyboard, I have two connectors, and they're not keyed, but they only run to one port each. Yeah, and this all fits together like so. I do actually think that's correct, that this should be now pinned together here, if this was to be mounted now. Just give it a little bit of fastening so it won't short out anything. Yeah, now we have fastened everything nice and good together. So then it's just about what should we do for power supply. And that means back to the service manual, because I won't connect anything to this until I know what way it should be coupled, if it's center negative or center positive. We do actually have a way to see that straight away, and we can measure this out, because if this is center negative, we should be able to actually check if there is a connection to ground from one of these. 1.4 ohms. I'm pretty sure that this connector is center negative, and the other end of the connection is in this way. So that's the outer part of the connector, and here you have some mega ohms to ground, but from the center here you do actually have 0 ohms. So this is one of those rare center negative connectors. So that means we have to do some rewiring. I do have a power supply where I have doctored this plug with only banana 4mm plug on the outside, and we might be able to use that. But then I have to go and get a power supply where I can connect this 4mm lab contacts. Yes, this is what we are going to test this with. This is a 16 volt adapter, and it's a Lenovo adapter or IBM actually branded, and it's a 16 volt power supply. And I made this little adapter here. I have this this adapter that I normally use, where you have this and you can choose what color if you have another power supply by turning this. But I don't want to ruin my IBM power, so I just made this short lead here that have this input for this barrel jack, and you have these two outputs here. And this is the other side, and this is the center tap, the S. So when I measure here, I can take this to volt. Yes, and we just plug this into the IBM power, like so. And we can measure this here with the voltmeter on volt, and this should be the center, it's the plus. So here you have 16.5 volt, and then I connect with minus on the center, and I take this one, the plus, this way, and then this standard connection that I made here will have minus in the center and plus on the outside. So this is the positive charge. So that means that we are actually ready to test this, and this is the battery leads for the internal battery, and we have not connected the external power supply battery. So we will just have to hop along and see what we got out of this. This is turned off, and I take this connector and I connect it here in the back. Now it should have power, and I turn it on, and there are some life. I can check the LCD and see if I can see anything. Yes, the LCD comes to life. It's really difficult to see this on camera, I think, but it's stated 640 bytes of RAM tested, and it doesn't say anything more. So I wonder if it's something to do with the floppy drives or something, or that it is because of no battery inside, because it's not starting, and the low battery light is lighting. Okay, now it comes more. Diskette removal or disk not ready. Please insert disk and push any key. I do have a bunch of floppy disk. This is my original copy, if you can say that, for DOS 5.0. It's a bit newer than what was with this computer. The disk drive lights up. I do wonder if it's possible to see anything on this screen with the camera. Just of now it's just a black screen, but we actually here got this booting. Hi mem DOS XMS driver, bad or missing display sys. Hi mem sys is requires on 80 byte 80x86 based machine. Warning from extra drive. This is typical DOS 5.0 stuff. A lot of strange thing there. And I've pushed the any key to continue, but there is nothing. So there was a bunch of stuff in this startup. But I will have to find a way to show this screen on camera. And as it is now, it's too much glare from the overhead lights. But if I turn them off, you will see the screen, but there will be some other issues here. It might be possible to read. And this has locked up now with this any drive. The last line is warning from extra drive. And this contrast knob can give you a bit better contrast. And I was lying to you. I actually said that this was not backlight, but it actually is. So this is a really surprise to me. I had a lot of these computers, and I do have some on the bench with me here now, and none of them have some kind of backlight on the LCD. But I will try a different boot disk. Floppy mechanism is not 100%. The disk is not springing out. And here I have one that's labeled startup. I don't know what's on it. Like so. It can also be that the BIOS settings are wrong because we have no CMOS battery. It comes loading, but what? Load memory max software. No. Yes, and it came about the same message as last time, that the DisplaySys is not supported, and that's because this is a CGA device where you have to have at least MCGA or EGA for that to work. But at least the floppy drive is not sounding bad. There are no excessive read noises that tips that you are having trouble reading something, but then again I don't know what he actually is loading, because I don't know what kind of startup disk this is. This is definitely taking some time. DRDOS release 6. Now it comes with some seeking sounds that can point to a read failure. This machine, as we saw, it was originally delivered with some earlier versions of DOS, about 3.2 or something, I seem to remember. Those versions of DOS, of course, was smaller and more versatile, so I will see if I can make a boot disk that will support that. The problem is that I have no good way of writing 720 kilobyte disks at the moment. Code page operation not supported on this device, and of course he is reading all these code page functions and it's not working optimally. Yes, and there you have a prompt. Yes, I think we can say that this actually is a success. I think we with a fair amount of certainty can say that this machine actually will work. I will put this, that was the multimeter turning itself off, I think. I will put a disk in this station and try to access it. I don't know if this disk is good, but I think it is. This is also a DOS boot disk, and it has the same problem as the other drive. When I try to eject the disk, it just stays inside. So there should be some spring lever here that pushes this out. That's not working optimally. Okay, there it came. It can be due to it has been standing still for so long time. But this is a really annoying thing, so I have to look into that. And that means that we have to disconnect the floppy drives and see what's inside. But then we have made ourselves a list over things to do with this machine. I will have to get a proper boot disk with those 3 something and the right drivers for the keyboard and the screen. Of course you don't need any screen drivers on this device, so it's only for the keyboard, and as this machine does not have a proper Norwegian keyboard, I'm not sure. You can see here it's actually writing the Norwegian characters based on the CABE no parameter, even if it's no DisplaySys and so on, and that's why you get this Japanese cent sign instead of the Norwegian Ö. That's some of the things that the DisplaySys should take care of. But the list of things to do on this machine is I have to test with the battery that we modified. We won't make it internal as this machine is fully able to boot without. We have to replace the CMOS battery with a CR2032 cell or something, and we have to clean out the floppy disks, and we of course have to put it back together. The first thing I will try to do is to get a DOS startup disk, and I might have to check to see if I do have an USB floppy drive that actually is able to write to 720 disks. And I do have this disk here, so I will try to use this empty disk to see if it works. Just this was startup, and this was the DRDOS, and this drive here. If I just yeah, of course I should have changed to the A drive first. Now he's looking up the format command here from the DRDOS disk. So this will be formatted with the system of the DRDOS, but with no other startup things if everything works. Press enter when ready. Existing DIS format is different. Continue, yes, no. And this was one of the things with DIS. It has a faster floppy format routine than MS-DOS. And for those who don't know, DIS was actually back in the day before Windows 95 was all the rage. There actually was market for competing DOS versions, and DIS was a reverse engineer version of DOS made by Digital Research, the one that beat Windows by some years with a graphical user interface with the GEM interface that was available on yeah, I think the Amstrad line of computers used that as their system. Enter volume label. Blå disk. I can't make a Norwegian O letter there. Blå disk with 2 A's. Transferring operating system files. Sorry for the lightning and stuff, but this is primary a workshop and not a movie studio by any means. So I do have some trouble with lightning, but I will try to find a way to have this suited better. And here you can see why this was going slowly, and 362,496 bytes total disk space, and format another drive. And he was actually formatting this as a 360 kilobyte drive, and we have to redo that. See if there are any help on the format command. Yes. So if I format B and /F for 720 and -S for system, and we try again. And since there are no catch or anything on the file system, he has to read the files from the disk. Specified F option is not valid for target drive, and that means we have to do some BIOS tweaking before we can get this right, because he thinks this is a 360K drive. So that was as far as we got today. So we might have to dig a bit deeper to come to the bottom of this, because I don't have a setup program for this machine either, so that is also something we have to remedy. So thanks for watching, and hope to see you again in the 4th installment of this series with the LT1400 from Tandy. Please hit subscribe if you want to be notified when we post another videos. And sorry for the bad picture quality when we also had to make the screen readable. So thanks for watching, and see you in the next one.